is a video that's going to discuss 1 and 2 step literal equations. A literal equation is an equation that has more than one variable. So for this equation, we have perimeter equals 4s, and this problem is asking for us to isolate the s. So the first thing that can be kind of helpful is just to identify, highlight, mark, circle, whatever, where the variable is. Anything attached to the term of the variable we want to solve for, we want to make 1. Anything that's not attached, we want to make 0. So in this case, we only have one term on the side with the s. It's 4s. And so we want to make this 4 turn to 1. So if we're trying to isolate the s, we would divide by 4, divide by 4. 4 divided by 4 is 1, so we would end up with s is equal to p divided by 4, or 1s, which of course is the same as s. So that would be for the first one step. This one, you'll notice that instead of having one term, we have 3 terms on the side with the b. So this would be the perimeter formula for a triangle, adding up the 3 sides, side A, side B, side C. We're going to isolate the b. So the first thing we can do is we can zero out. It doesn't really matter which term you zero out. I'm going to go ahead and zero out the a first, just because it's showing first. So we would have p minus a equals, and then we just have a positive b plus c. And then also zeroing out that other term here. So minus c, so p minus a minus c equals b. And now we have the b isolated. It's all by itself. You can use the symmetric property if you want. Just be careful when you write in the same order from left to right. So p minus a minus c. All right. So now we're going to look at a division one. This is distance equals speed over time. We're going to solve this for 2 different variables. The first time we're going to solve for s, and the second time we're going to solve for t. And they are a little bit different. So for the first one, we're solving for s. There's only one term. Remember, a term is something that's broken up by a plus or minus sign. So that's why on this one here there were 3 separate terms. And we have s divided by t. So if we want to make the t turn into a 1, we just multiply it. Now we have t over t, which is just 1. So we have t d, or t times d equals s. Or again, using symmetric property, we can write s equals td. When we're solving for t, it's a little bit different. We're going to use the same start. But there's really 2 different ways you can do this problem. We can't actually multiply by s, because if we did that, we would end up with s squared, which is definitely not what we want. And then we have s squared equals ds, which doesn't really allow us to isolate the s. So for this one, we can actually do 2 different things. You can either set it up with d over 1 and use it as a proportion by cross-multiplying. So d times t, which is dt equals s. And then divide by d on both sides. And that would give us t equals s over d. So that's one way you can use a proportion. Or you can write it the same way, d equals s over t. We can actually multiply by the denominator. And so that would just turn that into 1. So now we have td equals s, just like we did earlier when we solved for s. And then once we get to this, we can just divide the d from both sides, and that way t is isolated. So it doesn't really matter which method you use. Both ended with the same answer. Really, cross-multiplying is the same thing as kind of multiplying by the denominator. So, all right, a couple more. So this one here, it's a little bit messy and hard to see. I'll kind of make it bolder. But this problem here, we have 2x plus 4y equals negative 16. So we're again going to solve this 2 different ways. I'm going to solve for y first. You'll notice that on the side with the y, there are 2 terms. So we're going to zero out the first term, and then we'll go ahead and divide off anything that's kind of still connected to the y. So this here, we're going to go ahead and zero out the 2x. So we're going to subtract 2x minus 2x. You could also write negative 2x plus, or minus 16, that's fine too. And then we're going to divide both sides by 4. And be careful when you divide, you want to make sure you divide the whole side, so we get y equals negative 4 minus 1/2 x, or x over 2. And I went ahead and just simplified this part here, and that way you can kind of see that it just puts it in a little bit simpler form, since this one does turn to an integer. Now using the same equation, if we solve for x instead of y, we would zero out the term that doesn't have the x, so subtract 4y from both sides. Divide both sides by 2. Oops. There we go. And so you're left with x equals negative 8 minus, this would be negative 4y divided by 2, so minus 2y. And that'll be our final for that one. Alright, one more on this video, and then I'll post a couple other videos that are kind of some harder questions. So solving this problem here, we're solving for x1. This is actually, even though it looks like two separated terms, they're all connected because they're all being divided by 2. In order for it to be separate terms, our denominator would have to be a 1. So we're actually going to, just like you would do if you had a numerical denominator in an equation, we can go ahead and multiply by 2 over 1, and that's going to be 2 over 2, so that would then turn our denominator to 1. Once our denominator is 1, we don't need to write it anymore. And then, just to get x1 by itself, we would go ahead and subtract off that other term.